Hello everyone and welcome to the session of data science. In the previous session we have covered classification. Today in this session we are going to cover one of the classification algorithm, that is decision tree. Before moving ahead, I'd like to quickly introduce myself. I'm Neha Oja, working as a software engineer in Kpro Solutions Private Limited. Kpro is a leading provider in the field of analytics, data lake, machine learning, artificial intelligence, blockchain, cloud and mobile applications development. In today's session, we will be covering introduction of decision tree, its types, then we'll see a decision tree example, then we'll learn about the application of decision tree in different fields, and then we'll look into advantages and disadvantages of decision tree and the methods for fixing decision tree issues, and finally we'll learn how to build decision tree in R. So let's get started. So decision tree is an algorithm used for supervised learning problems of classification and regression type. Decision tree maps possible outcome from a series of related choices. It helps an organization to select one among various alternatives by comparing them on the basis of cost, probabilities, and benefits. It typically starts with a single node which branches with the possible outcomes. There are basically three different types of node in a decision tree. The first one is chance node, the second one is decision node, and the third one is end node. Chance node shows the probability of occurrence of a particular result. Decision node shows decision to be made, and end node shows the final outcome. Decision tree can be used to derive informal discussion and can also be used to choose best algorithm which will predict the best possible outcome. There are basically two types of decision tree. The first one is classification tree, and the second one is regression tree. In classification tree, response variable is categorical, means possible outcome can be either take yes, no, true, false, dead, living, spam, not spam, etc. An example would be when we have to decide an email is spammed or not, that will come under classification decision tree. On the other hand, regression tree, the predicted outcome can be considered a real number or it is a continuous number. An example would be predicting the salary of an employee. Now let's have a look at the basic decision tree example. So here we wanted to predict whether an individual is fit or unfit. So this tree mainly consists of two entities. The first one is a decision node and the other one is leaves. Decision nodes are the one where our data is splitting and leaf nodes indicate possible outcomes. So in this case, age, eat lots of junk food, and exercises daily are our decision nodes. And fit and unfit are the possible outcomes. Here, age node can also be called as root node because it is at the top and from here we are starting our tree. Eat lots of junk food and exercises daily can be called as internal node with one incoming age and two or more outgoing ages. The final outcome with no outgoing ages are leaf nodes. So this is a very basic example of decision tree. In real world, it's much more complex than this. Decision tree has wide range of application in different fields. Few of them are in the field of marketing, customer retention, fraud detection, and healthcare. In field of marketing, it is required to decide best combination of product and marketing channels to target specific set of customers. Decision tree helps an organization to retain their valuable customer and add new by providing good quality product, give voucher, etc. They analyze the buying behavior of customer and know their satisfaction level. It helps business to detect fraud beforehand and drops fraudulent customer. In healthcare sector, it classifies patients having higher risk from suffering from heart diseases, cancer, etc. So these are the few applications of decision tree. Now let's have a look at the advantages and disadvantages of decision tree. The most important advantage of a decision tree is it accepts both numerical and categorical data and very effectively handle missing values. It is easy to comprehend and also learning decision tree is simple and fast. These methods are now parametric, which means when a variable is not the discriminating factor, then it doesn't affect any of the tree variable. It provides visual interpretation of the situation which enhances communication. All of its branches show the factors involved in the decision making. So basically it is quite transparent in comparison to other algorithms. Among the disadvantages of the decision tree, the most prominent one is this: in these models can have high variance, which means a small change in a dataset can produce an entirely different result. It evaluates the variable one by one sequentially, not simultaneously, which means if we want to make changes somewhere, we have to do one by one. We can't make the changes all at a time. Also, if we make small changes in a variable which is closer to the root of the decision tree, then it can impact final outcome adversely. Now let's look at the methods for fixing decision tree issues. So first one is ensemble method. This is used for removing the problem of variance in decision tree. Ensemble methods are further grouped into two categories. The first one is bagging decision tree and the second one is boosting decision tree. In the bagging decision tree, we build multiple decision tree by repeatedly resampling training data with replacement and voting trees for consensus prediction. While in boosting decision tree, it feeds a weak tree to the data and it keeps fitting weak learners in order to correct the error of previous model. The next method is tree pruning. This is the method of removing a part of a tree which has lesser impact on decision making. It is performed to remove anomalies in the training data due to outliers. The pruned trees are smaller and less complex. There are two approaches by which we perform the tree pruning. The first one is pre-pruning and the second one is post-pruning. In the pre-pruning, the tree is pruned by halting its construction early, while in post-pruning, a subtree from a fully grown tree is removed to remove the impact of the outliers. So these are some methods available for fixing decision tree issues. Now we will learn building decision tree using R. So we will basically install and load the required packages, then we will explore the data, then we will create and plot the tree. So let's go ahead and see how we can do it using RStudio. For working with the decision tree, we need to install and load dependent packages. R has a package called party which provides function called ctree, which is used to create and analyze decision tree. So here I have listed the steps which we need to create the decision tree. The first step will be installing the party package by using install packages function. In the second step, we are loading the party package. Once we will install and load the party package, it will automatically load all other dependent packages. Here, since I have already installed and loaded my package, I am not running these two steps. For this example, we will be using inbuilt data set of R, that is reading skill. So let's first explore this data set. So we are using different functions like name, head, and row and column and summary for exploring our data set. Name function is used to return all the columns present in our data set. Head function returns the first few entries of our data set. End row will return the total number of rows present in our data set. End column will return the total number of columns present in our data set. And summary will return the summary of our data set. In case of the column containing numeric data, it will return the minimum maximum value of that column, mean and median, and also first quartile and third quartile. In all of these functions, we are passing the name of our data set as an argument. So let me run these steps one by one and show you what is there in our data set. So these are the column names present in our data set. They are native speaker, age, school size, and score. When I'll run the head function, it's returning the first 6 entries of our data set, and this is how our data will look like. When I'll run the end row function, it will return the number of rows present in our data set. So in our case it is 200. And end column will return the number of columns present in our data set. Here we have 4 columns. Summary function will return the summary of our data set. So in the first column, we have entries in character and string. So in that case, it's returning the total count of no and yes. And in other cases where we have numerical data, it's returning minimum, maximum, first and third quartile, and mean and median. So now we have an idea about our data set, about how it looked like, what is the total number of rows and columns present in our data set, what is the name of the columns, how is the data present in the column. So once we explore the data set, our next step is creating an input data frame. So here we are creating an input data frame from our data set by taking the first 105 entries of our data set. So let me create this. So I have successfully created my input data frame by taking the first 105 entries of our data set. Now I'll create the tree. So for creating the tree, I'm using ctree function. The first argument it takes is our formula, and here in this formula, native speaker is the outcome variable, while age, shoe size and score we are using as predictor. So what we want to do is we want to predict whether an individual is a native speaker or not when we have data of age, shoe size and score. And in the second argument, we are passing the data which will provide the values to these variables. In our case, we have passed input data which we have created in our last step. And I'm storing the tree created in a variable called output tree. So let me run this step and create my tree. So my tree got created. Now I'll plot this tree using the plot function. In argument, I'll pass the name of the tree. So here I have plotted my tree. So this is how my decision tree will look like. This one is the root node and these are the internal nodes. Here, by seeing this decision tree, we can easily visualize that when the score is less than equal to 38.3 and the age is greater than 6, then the person is not a native speaker. Similarly, when the score is less than 38.3 and age is less than equal to 6, then further the data is divided on the basis of score. One with score less than equal to 30.7 and one with score greater than 30.7. So if it is less than 30.7, then individual is not a native speaker, and if it is greater than 30.7, then individual is a native speaker. So this is how decision tree can be used in R for making prediction. Now let us have a look at the topics which we have covered in today's session. So we have started with the introduction of decision. Then we have learned different type of decision tree. Then we understood decision tree structure with an example. Then we learned about the application of decision tree in different fields. Then we have understood the advantages and disadvantages of decision tree and the methods to fix it. And finally we learned building a decision tree using R. So that's all for today's session. In the next session we will be covering confusion matrix. So we'll cover introduction of the confusion matrix, example of confusion matrix, and we'll learn the different terminologies used in confusion matrix. Thank you for watching this video. You can provide your valuable feedback in the comment section. You can also write us at feedback@kpro.co.in. To learn more about new technologies, you can subscribe our YouTube channel on blockchain, cloud, data science, ETL, data lake, DevOps, big data testing, and cloud testing. You can also follow us on YouTube, Facebook, LinkedIn, and Twitter. Thank you once again. Let's keep learning.